In this video, we're going to look at the mathematics and calculate how much energy we have to put into ice to turn it into steam. Looking over the mathematics, the heating curve of water. So here's our problem. We have 1 mole of ice at negative 25 degrees. And I want to eventually turn it into steam. So how are we going to do this? Well, the first part is we need to heat our ice from minus 25 C to 0 degrees C. And we have to use the equation heat equals mass times heat capacity times our change in temperature. Using the molar mass of water, we can find that the mass of 1 mole of ice is 18 grams. And the heat capacity of ice is a given, so you'll always be given CS or the tools to find it. The mass of 1 mole of water, you should be able to do that in Gen Chem 2. And our delta T is simply 25. So delta T is always final minus initial, so 0 minus negative 25. So we have heat equals 18 grams times 2.09 joules per gram Celsius times 25 degrees Celsius. Celsius cancel out, grams cancel out, and the amount of energy it takes to heat up ice from minus 25 to 0 is 941 joules or 9.41 kilojoules. So we should have a unit of energy when we do this, and I don't care unless I tell you specifically if your answer is in joules or kilojoules, as long as you're consistent. By that I mean all your answers should be in kilojoules or all your answers should be in joules. Alright, so we have ice now at 0 degrees, and we have to turn that ice into liquid. And our equation for that is the amount of heat we put in is the number of moles that we have multiplied by delta H of fusion. Okay, so this is easy. We have 1 mole of ice. Delta H of fusion is 6.02 kilojoules a mole. So Q equals 6.02 kilojoules. So for this, I just want to have you look at something. The amount of heat it took to heat up ice from 0 to 25 is just a fraction of the amount of heat it takes to turn ice from solid to a liquid. Because when we're going from a solid to liquid, we are breaking intermolecular forces, and therefore we need to put in a lot of energy. All right, so our water's at 0 degrees, and to get it to steam, the first thing we need to do is heat it up to 100 degrees Celsius. Again, that's Q equals mass times delta S times delta T. We already know mass of 1 mole of water is 18. CS is 2.09 joules moles Celsius. Delta T is final minus initial, so it's 100 minus 0, which is 100. Q is 7.52 times 10 to the 3 joules, or 7.52 kilojoules. Next, we have water at 100. We have to turn it to steam. We have to boil that. So Q equals N times delta H of vaporization. And I have fusion here, so that's a typo. That should be delta H of vaporization. That equals 40.7 kilojoules per mole. So the amount of heat needed to turn liquid to steam is 40.7 kilojoules, which was a lot more energy than it took to go from ice to liquid. Because when we're going from liquid to steam, we are breaking more intermolecular forces than going from solid to liquid. Therefore, we need to put in a lot more energy. Lastly, we want to heat our steam to 125. So we go back to the equation Q equals mass times CS times delta T. CS is 2.01. So Q is 0.904. And to get the heat of all these processes to go from ice at minus 25 to steam at 125, we just add up the energy of each step. That's all we have to do. And that's it for this video. I'll see you in the next one.